Okay, we're doing another example of the segment addition postulate, and in this case we're going to measure on my map that I have from Norton to Marysville. And I just found out that the sound doesn't work when I actually play the video, so we're measuring from the very outside of Norton to the very outside of Marysville for this one, since we're doing segments. Sometimes you might measure from the inside to the inside, but if you're trying to find a segment, it should be outside to outside, the longest distance possible for that segment. So we'll go ahead and play this video for a little bit to look at the numbers and then go from there. So I know you can't see that very well. I was just trying something new. So we'll talk about it and then go from there with the actual measurements. So if you get out a pen and a ruler, you can actually go through and measure this, and then you'll see what I'm saying by the actual measurement lengths that we get from this. So what I got, and I actually on one of mine I started at 2 centimeters and then I went to 6.9, and that one I went from 0 to wherever it ends up, which would be at 4.9. So either way would be a correct use. So one of my measurements in this case, we'll do it how I measured it in the actual thing, where we have our line segment. So let's say our segment is from N to M, Norton to Marysville, and this is going to equal the absolute value of x2 being our 4.9 in our measurement, minus our x1 being 0, and then 4.9 minus 1 equals 4.9. Our next one, we have a diagram here, diagram number 3, with F, G, and H. And on this F, G, and H, we want to go ahead and find the length of GH. Now, I know it might be self-explanatory and you can figure this out really quickly, but I'm going to walk through the steps of actually finding this out, so that when it's more complex, that we actually have a method to our madness. So what I'm going to do is start with our generic. So I'm just going to write this up here. We have our generic is AC equals AB plus BC. Okay, and then in this case I'm going to fill in, so the next line I'm just going to say, well, this implies that we actually get, in this case, FH equals FG plus GH. Okay, and since I know what FH is, I'm going to go ahead and plug that in. So this implies that we get 36 equals FG, we have that, 21. And then we're looking for GH, so plus GH here. Okay, now we need to move something. So what do you do every time you want to move something from one side to another? In this case, to undo addition, we need to do, hopefully you said subtraction. So we're going to subtract 21 from each side. Whatever we do to one side, we must do to the other side. So now we get 21, positive 21 minus 21, so that means this cancels out and becomes 0. And then we get 36 minus 21 over on the other side, and that should become 15. So we're left with, let's go ahead and do this, implies that we get 15 equals GH. Okay. Moving on to the next part. So at this point we have congruent segments, and then we get a character, you might say. This means congruent. So we have two straight lines, and then we have a little wavy line on the top of that. My drawing is not very good. The actual thing is much better. But two straight lines, and then a little squiggly line. The line segments that have the same length, direction does not matter. So we're just saying these two segments are the same length, and they must be the line segments in order for us to compare these. So my example I have here, determine if the segment JK is congruent to the segment LM. So in order to do this, we're going to do the same process that we had earlier. And then we can also write things before I kind of jump the gun a little bit here. If we come over here, if we want to write two congruent segments, so let's say we have a line here, This line is AB. And then we have another line here. It should be the same length. Not greatest here at drawing with this stylist. We have CD. And if these two things are said to be congruent, then we actually use lines and symbols to mark that. So in this case, we could use a line by itself. And if we have multiple things, we might use like these lines are congruent, and then we might have another set which we let one little dash mean congruent. But either way, this would basically say that we have AB equals CD, which really means that we get AB to be congruent to CD, because the length is the same, doesn't matter about direction like what we just said a little bit earlier. Okay, so now moving on to our main point here with example 4. So we're looking at JK and LM, and I don't care about direction, so all I want to know is distance. Is the distance the same? So if we look at JK to start with, so we have JK here, and we're only caring about distance. So J's here at this point, K's here at this point. I want to know which value am I looking at in my graph. So am I looking at the X direction or the Y direction? So I'm looking vertical or horizontal. In this case, we're looking at a line segment that's horizontal. So I want to look at the X part of this. So use our definition that we had earlier. If JK is our line segment, and this equals the absolute value of x2, x2 is 2, minus x1, so this is the second point, this is the first point. Just because we read left to right, you could label them either way, it wouldn't make a difference. Minus a negative 3, and then absolute value of that. So we have 2 minus a negative 3. 2 negatives make a positive, so we get 2 plus 3, which then the absolute value of a positive 5 is still 5. So then we look at the next one, LM, so line segment LM equals absolute value of x2 minus x1. In this case, let's go ahead and let the bottom point be our, or not x2, y2, because this is a vertical line. So let's let y2 be my second one, this M point. So y2, which is negative 2, minus y1, which is 3, absolute value, equals negative 2 minus a negative, or negative 2 minus 3, which is really negative 2 plus a negative 3, but that's a different story, equals negative 5. So we have the absolute value of negative 5. Well, the absolute value bars mean that we no longer have our negative, it's always positive, so then we get 5 equaling 5. So are these two line segments congruent? Well, we would conclude then that JK line segment equals LM, and therefore JK is congruent to LM.